Okay, so on problem number one, they gave us a diagram here of a scatter plot, and we're looking at the length of the running start and how far somebody jumps. And it seems like if the distance is not too far, that maybe the longer you run, the faster you will jump. And if you look at the dots, that appears to be the case because we tend to have a positive correlation here. And that leads me to believe that this cannot be the answer. And if we look at both options, it looks to me like the further your running start, the farther you jump. So let's see, the further you run, the further you jump. The further your running start, the less your distance. Well, that's not true. So this has to be the answer for problem number one. Problem number two. On problem number two, they are looking at the hours of the hours of exercise per week, and they're comparing that to the heart rate when you're not doing anything, you're resting. And they took several people and they looked at, how many hours a week they exercise. And then they looked at the resting heart rates, and they did a scatter plot here. And luckily, they figured out the line of best fit. So here it is. This is the line of best fit. So this is the model that we would use to predict the resting heart rate if you know the hours of exercise per week. And they want to know if somebody exercises for 6 hours a week, what would the resting heart rate be? Well, let's go to 6, which is here. And if we go to the model, which is going to be the line, so if we go up to the line, we can see that a person who exercises about 6 hours a week should have a resting heart rate of 55. So that would be the answer on that one. Number three. On number three, they give us the line of best fit, or the regression line, and we just have to make an interpretation here. And if we look at what's going on, it appears that as the number of toppings we put on a pizza increase, it looks to me like the price we pay for the pizza goes up. And that kind of makes sense, right? The more toppings, the more you have to pay for the pizza. So the question is, basically interpret the slope of the equation. Remember, from algebra, the slope is 1.5, right? This is slope-intercept form. And what does x represent? Well, x will represent the number of toppings. So it looks to me like you pay $1.50 per topping plus $12. So it looks to me like the answer has to be the slope is 1.5. It means that it costs $1.50 per topping, and then they'll add the $12 at the end of that. Number four, just estimate the value of R. Luckily, this is a multiple choice question, or it might be almost impossible to figure it out. But we know it's negative. We know that R is negative because we have a negative correlation here. But we do not really have a good line, right? These dots are really, some of these are nowhere near the line. Some of them are. So it looks to me like it cannot be anything close to -1. So I'm going to claim that -0.72 is the best option. Number five. Now, number five has a good positive correlation, right? We're going upward from left to right, and it's almost a perfect line. So I'm going to choose something very close to +1, and the best option is 0.99. And last but not least, we have a table here. And the table is not quite completed because I don't know the answer here, right? For some reason, we don't have that, or maybe we couldn't read it. And I guess we'll just have to throw this out, but we can still put the rest of these dots on a graph, and we can look at the scatter plot. And if we want to know the line of best fit, then we can just go to our trusty calculator, and we will put the values into the calculator. So let's see, Teachers
in the attic, would you please send someone?
Let's do that. If we go to the calculator And first we go to Stat, Edit. And the first thing I need to do is I need to clear. Do not hit delete. You do not want to delete the lists, but we want to clear the list. So select clear and enter. So that will clear the lists out. And now I'm going to go back and I'm going to plug in the X values in list 1, and I will plug the Y values in list 2. So if we go back to the problem, we can see that X is 2, 5, 10, 15, and 20. The Y values are going to be 1, 25, 21, 32, and 41. So we'll put those in the calculator. I've got 2, 5, 10, 15, and 20. And remember, we have to make sure that the Y values line up with their corresponding X values. So that's going to give me a 1, a 25, a 21, a 32, and a 41. And once I get all of the data entered, I'm going to go back to Stat again. I'm going to calculate. I'm going to select linear regression because I want to look at the regression line. I'm going to use lists 1 and 2 for X and Y respectively. And when I hit calculate, notice that the slope is 1.82. Let me see if I can get my pen here. Notice the slope is the A value, 1.82 approximately, and the intercept is 5.02. So that would give me the regression line. So if I switch back and look at the options, I will be able to see that the answer is going to be this one right here.